Okay, hello everyone. Welcome to another Wolfram Language Design Review, part of our incremental language development series. Okay, our first topic is SoftMax.
Yeah, we talked about this a couple weeks ago. You proposed having a standalone SoftMax function, and then we had decided that we didn't need it because we have SoftMax layer. And then
the question is it a useful thing? I mean, a SoftMax with a temperature, it seems like that's a thing people, I mean, maybe it's not used outside of machine learning. I'm not sure.
That was kind of my claim, is that you can get it through the layer pretty easily, and I've never seen it ever used outside of machine learning. And so, getting it through the layers, I think how you'd expect to get it.
Okay, yeah, it's really true. It's never used outside of machine learning. I mean, I had a very specific use case because I was trying to describe things admittedly related to machine learning.
Hint, yeah.
Right. All right. We'll drop it again. I might need to be reminded yet again. Okay, GeoNearest.
Yeah, so we have Francisco and Jose here, but this was a discussion item we had on either core design or ILD about modifying the behavior of how GeoNearest works with a GeoPosition with a list of positions inside it.
So the idea here is that in nearly every place, GeoPosition of an array is interpreted as the array of positions, except for the second argument of GeoNearest, which does some sort of grouping. And we want to change that to be consistent with the rest.
All right. GeoPosition of a list usually represents a collection of points.
Exactly.
Right? So, and so
in GeoNearest, there are two possibilities. Are we referring to the respective nearest positions to respective capitals, or to the capital that is closer to the group of positions?
Well, but does it have to be a one-level list?
We could generalize it as far as we want.
Right, but the question is it threading?
Currently not, but we want it to thread.
And what does it do if they're, okay, as opposed to saying, you've got a cluster of points, you've got another cluster of points, what is the closest approach between these clusters of points?
Right.
Now, I'm confused here. I'm very confused. If GeoNearest has an extended region, a country, for example, I mean, what does it mean? Which country is nearest to which other country? So here, like, look, for example, let's say I say GeoNearest of, countries in Europe, and then I say North Pole. What am I going to get? So what did that just do? I mean, that seemed to do something reasonable. It said which country has a point that is closest to
the North Pole.
So this is correct. Now imagine that in the second argument you had list GeoPosition North Pole, GeoPosition South Pole. So now we expect to get two different results, right? Because we have two.
You didn't put a list, did you? Oh, no, never mind.
I'm just trying to figure this out. What?
Wait, that can't be right.
So that's some territory. The Netherlands.
Yeah, there must be some territory of the Netherlands.
Yeah,
right.
You didn't use GeoVariant of principle.
But why did South Pole come back with Antarctica?
Why
didn't it come back with the geographic South Pole?
That's a Wolfram Alpha question. I don't know.
Somebody answer that. That would be a good thing to look at, please. Looks like a bug to me.
There are assumptions there, right? So, probably.
I see. Assuming South Pole is a continent, why on earth would one think of it as a continent?
People, I think, that's pretty common when people say, people use traveling to Antarctica and traveling to the South Pole as pretty interchangeable, I think.
Okay, all right. So the question is, if we had two things here,
No, yes.
If we have a list of two things, it'll
will thread.
give us a list of two results.
Exactly.
that's what it does right now.
Yes.
Okay.
And we still want to keep that. Now, the thing is that imagine that you put GeoPosition at in front of that list, so that we get a GeoPosition array in the second argument. So currently, it's going to say, oh, I have a single thing. And so it gets the country which is closest to both.
Which
Well,
doesn't seem
closest to
obviously
one
wrong
of the
to me.
points,
So,
right?
yeah.
It's giving you the min of the mins.
Exactly. Yeah.
But now, what
this
about if these were extended objects here?
well, GeoPosition would still construct GeoPositions.
Okay, so let's, for example, let's say I say China here, for example.
Presumably the most useful thing though would be the, you know, the shortest line, right? Like the length of the shortest line is the distance.
Yes. The thing,
Right. And given that Russia and China share a border, I mean, that's a pretty
yeah, right. Okay, but I mean, so let's say wow, Russia wins them all.
try
Okay,
so you're asking
a bunch of
Israel,
Asian
right?
countries.
You know, the problem is you're so far east that, you know, Russia is the
Okay, that sounds plausible. Okay, but so now what is the proposed change? So
Yeah. So consider your first two inputs. They are different. We are proposing that the second one should give the output of the first one.
I'm not buying it. Why? I mean, why isn't a geoposition of a list of things like a composite geoposition thing?
No, because in most other places, we consider that GeoPosition array is equivalent to the corresponding array of GeoPositions. For example, in GeoDistance, if we have two GeoPosition arrays, it would just thread as if there were lists.
right now.
Is there another obvious way to
right,
make the composite, like GeoPolygon or something?
We have a GeoGroup, and that's at the very
GeoGroup.
end of this, we are proposing that wrapping things in GeoGroup will kind of group them together and consider them as if they are one.
So it would be GeoGroup at GeoPosition of the list
Yeah.
is a possible representation of the
Of the group of the points, rather than
Whereas you want to make geoposition of the individual points be like the list.
exactly, because that's the rule we follow in other places. It's very useful
What
for
specifically?
try GeoDistance. GeoDistance of and construct two random points of 10, for example.
well, couldn't he just take the GeoNearest input and change it to GeoDistance?
Yes, it's just random GeoPosition is a very easy way of creating random.
Yes, but here, if I say
input.
geodistance,
Right. So
that's
you see,
weird.
you get a matrix of 51 times 2, which is the list of 51 countries and the list of 2.
But that's not what I'm getting here, right? Because the GeoNearest here,
Well, GeoNearest returns a list because
I'm
even
totally confused. This doesn't seem right.
No. GeoNearest has to return a list because in the case in which there are two countries at exactly the same
Oh,
distance,
I know.
right? Like nearest.
I don't understand why this is making this list of 51, however many countries in Europe. Why isn't
Because
this giving me?
it's threading, right? There is a
But
there is
that's
a list.
wrong. I mean, I don't understand.
That's what
This
Nearest
isn't
does,
threading.
for example. Nearest threads like this.
Yes, nearest threads in the first argument, but not in the second argument. Sorry, it threads in
Sure.
both arguments, except for the fact that with a GeoPosition in the second argument, it doesn't. It's an exception.
Oh, hold on. Nearest doesn't do. I mean, nearest of a bunch of, if I just say nearest of range of 10, right?
Yep.
To do nearest a range of 10, comma range of 5, you'll get a thing that's 10 by 5.
But first of all, I get that, right?
Yep.
And that's
Right.
not analogous to this because
No, because you didn't give it a list of, you gave a list of North Pole, comma South Pole. instead of a single thing.
Right,
It's totally
exactly.
analogous.
But I'm complaining about this down here. I'm complaining that geodistance, I would expect it to give me the distance between, thinking of Europe as a blob, the distance between Europe and I'm not yet addressing whether this is listed or not, but let's say this says comma North Pole, I would expect it to give me the distance of sort of the closest distance of anything in Europe to the North Pole.
Right. Well, this is the ambiguity that I think is being solved, right? Is that if you have a list, it's unclear if, like for example, in graphics, we usually interpret, a list as kind of like the union of all these things, right? Like if you want to show 2 points, you give a list of, here's a point. I guess you can wrap up the points, but you know what I mean. You can give a list of the 2 things. But the point is, here, you need to know whether you're talking about the individual ones as a list or as a group. And that's what GeoGroup resolves, right? So I think the consistent thing is to do what this does, which is if it's a list, you thread. And if you don't want it to thread, use GeoGroup.
Okay, exactly. Remember, nearest never threads in its first argument because it's asking which of those first argument elements is closest to the second argument.
Yes, but that's a particular thing of nearest. It threads, for example, in the second argument.
What if the first argument of nearest is a depth 2 list?
Then it's
going assume
to
that they're points.
Exactly,
like higher dimension points. Yeah.
Yep.
I see. So it hasn't had to address that issue, but GeoNearest would have to address that issue because it doesn't, GeoPosition is in 3 dimensions.
Well,
it's in 2 intrinsic dimensions.
As long as it is a list of geopositions, everything is clear still.
All right, so the proposal is that, go ahead.
So, just one thing. So this question has appeared because when you have many geopositions, it's very useful to have a single one with a packed array inside. And so that's what we are trying to do here, is to take advantage of that.
I really hate that this quantity. Okay, so this is saying
that's the distance from the group to the North Pole and the distance from the group to the South Pole.
Can I find out what the element of this that is closest to the South Pole? I mean, I know it's the Netherlands, but can I find out where it is?
You mean which exact geoposition?
I want to know, is it the Dutch Antilles? Where is it? What is the
you want the geoposition in Europe that is closest to Antarctica?
Yes. How do I get that?
We don't have that functionality yet.
But we do have it for regions, right? That's
yeah,
called.
It's confusingly region nearest, I think is what it's called. If I remember right.
Oh no.
Yes.
Right. Region nearest doesn't tell you which region is closest. I guess you could do that with normal nearest. We could have a distance function that operates on regions. Right. It tells you which point within a region.
So in a sense, would region nearest itself operate on, okay, so which point within a region? So that's GeoGroup of this. So would this just work?
I'm not sure if your region function works with your position.
What is this? A correctly specified?
It just didn't accept a geo. No, it's a fine error. It's just saying you didn't give it a region. It expected a region.
No, I understand that, but read the error message. It's crazy.
Maybe, okay, yeah.
Needs a verb.
Yes.
No, it's correct. I mean, it's grammatically correct.
Oh, expected. I'm sorry. I'm sorry. I didn't read it properly. Okay, so what you guys are arguing.
Cool.
I mean, just tell me, this is not an efficiency hack story, right? Or is it an efficiency hack story?
It's more a consistency thing. In nearly all geo functions, a geoposition array means the array of the geopositions, except for the second argument of GeoNearest.
Did you want to have we haven't really, I'm not sure we've done exactly the example, right? So the case is like if you do GeoNearest of, you know,
Christopher, do you support this change?
Yes, definitely.
And it's obvious, you claim.
I think so, yeah.
So if you evaluate all these examples there with Grenoble, etc., I think you'll see that there's a lack of consistency at the end.
Of nearest.
Of that one, it should return of GeoNearest. The one after the proposed change is the one returning only Vaduz.
I'm sorry,
Right.
So,
well, more basically, though, I mean, you can see that the GeoNearest, you know, when you thread the geopositions, it gives a different answer, right? Isn't that's kind of the main problem case, right?
Exactly.
Yeah. So you see that result that you have your cursor
the list
on
of
one below it are different.
Exactly.
Does it flatten? I mean, if I gave 2 levels of list here, what would it do?
That's probably not understood, I think.
Yeah, I'm not sure where, like, it already supports
thread, right? Yeah, right.
Well, it does.
It preserves the structure.
So it's listable in some sense.
I think this is sort of outside, like that's not even related to this proposal. Like that's just how GeoNearest and probably Nearest mostly works, right? Like I think we're just talking about what it means when you have a geoposition.
We have a single geoposition. And the question is it like the list inside it, or is it like a single object?
Exactly. And I think that GeoGroup is a good solution because, right, if we decided that, if we decide that it represents many positions, then you can use GeoGroup to disambiguate that, no, I actually mean one position, I mean one object.
Right.
But if we assume it means one object, there's no obvious way other than calling thread and making some gigantic expression with a bajillion geopositions, you know.
Right. Wouldn't it be nice if the autocompleter hinted you something about GeoGroup?
Yeah, and I think the most convincing argument is that is comparing the penultimate and anti-penultimate inputs on the screen.
Anti-penultimate, you mean this one here?
Correct. Right. So why does that one give one answer and the one below it give 2 answers?
Okay. If you guys are all convinced, I'm okay with it. But I would like to just ask, what do we do to advertise GeoGroup, which I have definitely forgotten about multiple times?
Well, I guess we can add lots of examples using it to GeoNearest now that we're making
we should certainly do that. But I mean, I'm asking here, for example, can we let's see. I mean, I'm just trying to think whether there's any way to give some autocomplete hint here. I can see that as being an interesting pattern for other places too.
I think we have the wrong set of people.
Okay, so can somebody bring that to the user assistance meeting, please?
We could put a dedicated users message in that has GeoGroup explicitly in the users message.
That would
and then useful. It would show up in the little left-hand down arrows, you know.
That's a good idea. Yeah.
Yeah, that's a good idea. I agree. And this doesn't even show that this shows lat long. Oh no, that's
GeoPosition. You want GeoNearest.
Right.
Right. So you'd have lock, and then you'd have I guess it would be the second one. It would be you know, a GeoGroup of lock, and then you'd have all the others would have lock spec or something.
Yeah. Okay. All right, something like that can be done. Okay. Good. I think we're turning to a different topic then. And I know Christopher has to go.
And I have to go, so I should, yeah.
See you.
So
Bye.
these are the last handful of things from some of the older design documents, specifically functions and features that we either have in alpha or have been using and exposing as part of Wolfram Alpha Notebook Edition, which are not in the language. Some of these have been moved to WFR and are worth considering if we want to move them to system. And
I'd love to get, I mean, I don't have, okay. And Roger isn't here, I assume.
Yeah, we don't have Roger and we don't have Devendra, so I think it might be hard to talk about these. I mean, I have some comments as somebody who works closely with the calculus team, but you know.
Well, I mean, the question, you know, we would like to support more kind of sort of useful, sort of more elementary math kinds of things. I don't know whether these are they. What was your comments, Satai?
Well, I mean, personally, I find it a little weird that you know, that stationary points. I mean, I would argue that the stationary points are, you know, the x values, and this is giving me a rule for the x values and the y value.
I agree. I don't think it's right.
Yeah.
I don't think it's right. I mean, I can see stationary points being, you know, solving the derivative equals 0 problem.
Right.
That would be useful. Now, you know, it's kind of like argmax versus, you know, this is the, where is it 0? Where is the derivative 0? And then what's the value of the function at that point? It's a different issue because you might be interested in what's the second derivative, or you might be interested in all kinds of things. And to my mind, it would seem more useful to have something where it's like almost like root sum, where you can do something where you can say, you know, summing over the, or doing something over, listing over the stationary points. What is the value of this quantity? Is that crazy? I think we have the wrong people here for this meeting.
So I agree with everything that has been said and the reasonings presented. Part of the reason that we wrote these in the way that they are was because we were thinking about Wayne and we wanted to be able to have the full presentation of information, where for the more elementary math consideration, when you are asked to solve a problem like find the inflection points or the stationary points or critical points, etc., you want all of the information and not just part of it.
Yeah, I get it. I get it. It's solving a different problem. Right. I mean, it makes perfect sense for Wolfram Alpha Notebook Edition.
Yeah.
It just doesn't.
And I think the only point I would add to that is that I think that should we make the change, should this become a system function and the changes discussed be implemented, it should be clear in a straightforward way how to get from one to the other, which obviously is doable. But
Yeah. That's we'll worry about the bridge later. First, we figure out what we want to, where we want to go. All right. Well, I mean, we can't really discuss that without these other folk. And I don't know. Let's take a look at some of these. Is that a thing that we actually, I mean, we certainly have that. And it's kind of an interesting thing. And I agree with you. It will be a nice thing to have here. I mean, hopefully find sequence function, maybe.
So
we're about to see some, you know, new LLM-based versions of find sequence function. I don't know if it's going to work, but it's something which is conceivable. Go ahead. You're going to say.
Well, I was going to ask. So is this like, you know, that's like pi squared over 2? I'm not sure what the output of this is supposed to be. Yes.
It's the analog of what's the thing? I mean, we've got rationalize and we've got also root approximant. What is that and why is that useful? How many times do I have to make this point? It's not useful. Just not useful. We have the wrong people here, I guess, for this.
I mean, there's a ticket for it. It'll happen eventually.
I hope it will happen soon. It's really bad. It's really kind of useless what we have here. But look, I don't know whether this is what do I say here? I say primitive polynomial or something. What do I say?
What are you wanting to do?
I want the polynomial of which this is the root.
Try first.
That's a horrible thing. But okay, but that's that thing, a root of that polynomial approximates that number. So this is there are two things. We have rationalize, we have root approximant. The fine number representation, I'm not sure it's the right name, would be the thing that will find the representation in terms of, presumably by default. I mean, if I type that in, you know, if I do a Wolfram alpha version of that, possible closed forms. Here we go. Why does it have an underscore there? Why does it not have a subscript? Anybody know? On the website, it surely has a subscript. Should I try it?
I would believe you. My guess is there's some
Probably.
formatting issue.
Or an API issue. Right.
Well, somebody should investigate.
Yeah, but nobody relevant to that investigation.
I'm aware. Nobody's relevant to that investigation is here. That's why. Oh, interesting. Okay, so it's correct here. So who from project management is here and can report that, please?
Avery. Yep, I can report it.
Huh. Wonder what it's going to do here. I don't think it was very useful. Didn't find any more representations, but this is what we're talking about. But I mean, you know, if we're going to make this into a system function, and I do think it would be nice and useful as a system function, we do need some ranking of these. I mean, we have a default ranking that was based on essentially how commonly these things are talked about in the world. We should look these days in Common Crawl. I mean, we have looked, we did it in Archive years ago, looking at how common each of these constants is to decide how much we should rank it here. You know, I realize I didn't look at our comments on our chat about GeoNearest. Seth is commenting, there's a more basic issue with GeoNearest inside query. GeoNearest works if the query is working on, for example, a list of associations, but can give errors if the query is working on a data set. Who here knows about that?
Yes, this should be generalized. I think we have received a report from him pointing this out, that GeoNearest should work on dataset. It will be generalized.
Okay. And Sandra is commenting, GeoNearest can't really have the notation. You have a nearest asking for index, distance, element, etc. That's an interesting point too.
So what's the comment, that it can or that it should not? Or?
Well, I don't know. I think it would be nice if it could have, but maybe it can't have for some reason. Let me look.
I think we have been exploring recently.
A rule in the first argument means something different.
Oh. No, does it?
Well,
oh no, I guess it wouldn't be ambiguous if you have string names.
Exactly. We have been looking at that recently, Francisco, right?
Right. I mean, that's exactly analogous to nearest, right? Nearest also has that same.
Yeah.
Yes. So arrow property sounds like something we can do, and that way, that looks like a really worthwhile thing to me.
Yeah, we are actually working on that. I think we had recently discussed this.
Fine.
Yep.
All right, let's go back down here. Okay. So what I'm saying is, for this number representation thing, I mean, this is a Michael Trott production and Eric Westing production, I think, originally. Here.
Pretty sure.
Right. So, I mean, I would supporting that in the language. However, I think we need to think a little bit about the sort of we probably need a second argument which describes the class of constants that we should be assuming, so to speak. Am I talking to the wrong set of people here? Nobody knows. If I'm saying it's one of those,
If no one
right
answers, that
person
means
here?
yes.
Yeah, I mean, Michael was supposed to be here, and then he had to pull out for
Okay,
an OpenAI discussion. Yeah, so we can try circling back with him. I need to check in with him and Eric about something later today anyway. So
okay. Okay. Look, I mean, the fixing of this really should go along with the fixing of find formula, which really should be modernized. I mean, I think, and I don't know exactly where that's going to fall, because that's a thing where, you know, that is a combination of symbolic regression and modern machine learning methods. Find formula as it is right now is using a generation, you know, not a human generation, a technology generation ago of machine learning methods. Maybe again, is there nobody here who knows about it?
I don't believe so.
Okay. Okay. Hint for the next one of these meetings: for goodness sake, get the people who actually know about these things here, or don't put them on the agenda. I mean, again,
This was the suggested group of people.
Well, am I rolling here? Anybody here who can represent algebraic code data? That's an EdPeg production, as I recall. Okay.
I think Michael's the missing piece for all of this stuff. Sorry to say.
Well, I mean, algebraic codes, I'm not sure that's Michael particularly. That I think that packaging, there's several other people who know about that stuff. It's something where, you know, the question of what we'd really like is something which does a useful end-to-end thing of giving you an error-correcting code for a particular situation. And I think that's going to require a bit more understanding and heavy lifting. I mean, algebraic code data, I believe, and that's
I don't even know what frequency allocation data is.
It's FCC and what is it called? International Telecommunications Union, ITU.
Oh, okay. That okay. Not non-mathematical frequency. Okay.
Yeah, right. If I say 567 megahertz, it's going to tell me, hopefully, that is a UHF decimeter band. Its primary use in ITU region 2 is broadcasting. I wonder how I get the use in other ITU regions. That seems like a mistake here. We should have a pull down there for that. Again, Avery, if you can make that suggestion, that would be great.
Yep, got it.
If I say ITU region 3, I wonder whether it understands that. No, it should. Oh my gosh, it's talking about a place in Nigeria. Well, actually, wait a minute. What's this? Radio topic. Ugh. Well, that's very confused. That should work as well, because that should be a geographic region. That makes sense. I think this is stuff that was let's see if I say okay. As well as a music act, apparently. Okay. All right. Anyway, I don't know. I mean, that should certainly be a WFR function, the frequency allocation information. Whether that's something that deserves to be in the language, I'm not sure.
Okay.
Yeah. And I mean, it also is the case that there's things like ITU region, whatever, should be geographic entities, just like South Pole and North Pole and so on are. Am I making sense? Again, we probably have the wrong people here for that. Okay, packing data.
So we looked at this really briefly a couple of months ago and said we should have some of this. The question is, do we want to have a dedicated packing data function that then pulls out this information, both the visualization and the data set that it provides are potentially useful. I mean, the pods on alpha have more info in there as well. I think there's a link at the bottom of this section.
Yeah.
Basically place N shapes inside X shape.
I know.
Yeah.
I know, it's pretty cool, actually. I hope people know it's there. One kind of suspects they don't. If I say pack 10 squares in a disk, does it work? Oh yeah, look at that. What about if I say n pentagons? I don't think this is going to work. Nope.
Yeah, I believe there's currently a fixed set of polygons.
Yeah, I'm sure there are, because I'm sure, but I'm sure this is really related to that function whose name is just horrible and I always forget it. The piano mover function. Region, what the heck is it called? Region erosion, maybe? Anybody know what I'm talking about?
I can't think of the function name off the top of my head.
Well, here, this is, I think it's region erosion.
No, yeah.
Or is it region dilation? I can never remember. Yes, I think it's region dilation. So this is the thing that, this essentially is convolving a disk with a triangle, I think. Which turns out to be, I think, what you need to know whether a piano of a certain shape is going to fit around a corner as you try to move it. Do you understand what I'm saying?
Yeah.
These are really nice. These are really nice. I mean, the generalized case is surely you've got a list of shapes and you're fitting them in a given shape. How can you do it?
Yeah, that was kind of my initial question is, is this kind of a X data function where, we have certain
I think it's a computation function and we know certain cases cached.
Yeah, okay.
Because I can see that this is relevant for spheres inside spheres, all kinds of things like that.
Okay, so maybe something to at least run by the regions group as well and see.
I would think so. I think it's, I mean, I think the general problem is very hard, but I think it might very well be the case. I mean, I also wonder, seems like I don't know how important this is, but it seems like another one of those when in doubt, use machine learning type problems, because it's probably the case that from knowing what the optimal configurations are for lots of shapes, you can guess what it's going to be for some. I mean, like if I look at this thing here, and then I look at squares, I don't know, maybe there'll be no relationship. I don't know. Let's see.
How many
that was
spike
packed on one side.
Yeah.
Not much. I see. This is packing it in such a way, if I say pack 11 squares in a disk, oh boy, this is a complicated optimization problem. I mean, because we have something a little bit like this in, sphere points is again slightly like this. Am I making sense? I mean, if I say, and that would be probably, I don't think we give a lot of services for this, so to speak, if you get what I'm saying. It's just those are the raw points. And if I say, sphere, I don't know, 0.2 or something around that graphics 3D, it's not telling me what the, okay. Presumably if I were to say, Yeah, I mean, so that's cool actually. Oh, look, look at that. It's an icosahedron. What do you know? Or is it, no, it's a dodecahedron rather. Right. And presumably if I say 21 points, right, this is a very analogous thing in my view. But again, we're not providing a lot of, I mean, we're just providing the raw data of the points. We're not helping you by doing these visualizations particularly. But I think one of the points that is in here that is not in here is this is giving you the best center points. This is also giving you the actual size of the subregions that you need. I think we have the wrong people here. I'm sorry. This doesn't seem like the right discussion.
Right. I mean,
okay.
This was the list of attendees that Michael suggested last time.
Okay. Well, I mean, I think we don't quite have the right thing here. So, is there anything else we can cover in this meeting?
I have a list of a couple of WFR functions we're going to look at next time that I can send you, at least since we.
What are they? Maybe I can just find them.
Yeah, the so.
Oh, I can go. Yeah, go ahead.
Yeah.
Go ahead.
So key sort like was actually something that Bob submitted. We have a handful of association functions I'll send along, but that one was at the top of the list.
What is this?
You have existing ordering and you want to sort your data like that ordering.
I understand. So in an ordinary list, I don't understand why you don't just take this. In an ordinary list, what you would be doing.
And in this case, I don't want to lose any values, like anything that's not in the original, in the predefined ordering. I just want to put at the end in the original order that it was.
Okay, so that's the difference. So I mean, otherwise, because
you
if
could
I
just do
have
key
a
take,
list,
yeah.
I would just do the permutation here. So okay, so the issue here is that which is not mentioned should be put where? At the end?
Yes, maintaining the original order. Right. It's a sorting function. It's not a taking. It's not a, part function. So you don't want to lose things. You don't want to add things. You just want to reorder.
I don't understand why it isn't a default, some kind of thing in key take. Where it says, because key take usually would have take these, right? But the question is, what happens if there's a default? In other words, if you put all into the list of or something, that isn't quite the right way to do it. In other words, if you had something here,
I mean, I also have a sort like that isn't about keys. That's basically the same thing for the values or any list.
So in other words, it's putting the values that you call out first and then leaving the rest separated.
Right.
And why isn't that? Let me think. I mean, if you just broke the list into two pieces, the one that has the, I mean, the
I think that's what it's doing. Yeah.
This isn't floating my boat particularly. It doesn't seem like, I mean, it seems like it would take me longer to figure out what on earth this function will be called than
so this is a concept that applies to all sorting functions. In effect, this is providing an ordering function by saying, I prefer these objects to the other ones.
Right.
Right.
Right. It's just a convenience for defining an ordering function based on data.
Well, maybe we should have it be one of these sort of wrappers that defines an ordering function. I think we should probably declare a little bit of defeat on this meeting. I think we don't quite have the right stuff set up for this. Yeah. Okay. Anything else you think we should cover right now?
No, I think we can wrap.
Okay. All right. Good stuff. See you guys soon.
Bye.
Bye for now.